All right, so now that I've explained what's going on, let's just take a look at the slides here. Okay. Oop, I got to make sure I click on here. So we're on the slides. There we go. Do athletes, you can watch the slam dunk. Oh, I've already been here once. So do athletes defy gravity? No, nobody defies gravity. Some people are more powerful and can jump a little bit higher, but I think there's a human time limit that you can be in the air, and it's right around 1 second. Now, now you might be saying, well, wait a minute, high jumpers look like they're in the air. Well, think about it. They're leaping in the air from their feet. Their feet are not hitting the ground. They're stretching their feet. So they're going from their center of mass is at a certain height, then they're going up higher and then falling lower. So they're in the air a little bit longer. And of course, pole vaulters and stuff like that. I mean, they're using a different means. We're going to get to pole vaulting at the end, and in section 3 of this whole hang times, pole vaulting and flopping, or whatever the name of this thing. Hang times, homers, fouls, and flopping. Okay. All right, slam dunk contest. You can watch that. It's kind of fun. There's nothing on the in the little mini lesson or mini quiz 10 on it, but hang time. There are a few questions in the hang time video on this. Okay, that are just in general, like how long was Jordan Farmar in the air and things like that, and a few, like 3 or 4. There's only 9 questions on the whole mini lesson. Okay. All right. So here we go. Now, this is what I was talking about in the opening video. You push down with your feet and push off. You push hard on the floor, and the floor throws your center of mass up in the air. Okay? So how does one jump? Third law, LeBron pushes on the earth, and the earth pushes up on LeBron. Okay? I think that's an early picture of LeBron. All right, how quickly will the diver on the 10-meter be going immediately before entering the water? Okay, so we've got a conservation of energy, the diving example. We've seen this before. All right, so before he hits the water, we've done this. Energy before equals the energy after. So 1/2 mv squared equals, then all those cancel over there, and we wound up with square root of 2gh. Okay, so we need to figure out the velocity that you need to push off the ground to get to a certain height using this principle. All right. Okay, so hang time equations, they look complicated. This is because we're on the y-axis. They're really not. We will go over these. Let's take one step at a time with some problems. Let's do the hang time physics. Okay. All right. So there's it on the. So we're gonna look at. The first thing I'm gonna show you is throwing a ball in the air. Okay. And this trips up my 210 students. You can watch this. You can watch the next video, and you'll learn the math. You'll learn the equations for doing the hang time, and then we'll also do it together. When we go through the exercise. Okay. So let me record.